Hey, it's Mr. Lum again. Anyways, we're going to do some calculations involving KB. Last time we looked at some calculations involving Ka. So, here we go. This one says, what is the pH of 0.10 molar Na2SO3? Well, as we remember, Na2 is a spectator ion. Okay, and so we're going to write a net ionic equation about this one. So we're going to write SO3 2 minus, and if we find that on our table, we find SO3 2 minus right here. That's going to combine with water, and that's going to form HSO3 minus. Okay, so this is a base, and OH minus, and that's why it produces a base right here. So we're going to make a quick little ice table right here, and this is going to be, our initial is going to be 0.10 molar, and this is going to start off at 0 and 0. We don't really care about this one because this is a liquid and we're not going to count it. This is going to shift right in order to reach equilibrium, and therefore this is going to decrease by a factor of x. This is going to increase by a factor of x, and therefore this is going to be 0.10 minus x, x, and x. Okay, before we go any further, let's find what is KB of this, because this is our Ka. Okay, so we're going to need to find our KB. Okay, so our KB equals our Kw over our Ka of our conjugate acid, right here, and so that's going to be 1.0 times 10 to the minus 14th divided by 1.0 times 10 to the minus 7. Okay, now if you do this math, it's kind of weird and interesting. It doesn't always work out this way, actually rarely ever, but our Kb actually equals 1.0 times 10 to the minus 7. Okay, it just happens to work out that it's the same as the Ka, but that does not always happen. Anyways, let's write a Kb expression. Kb equals the concentration of HSO3 minus times the concentration of OH minus divided by the concentration of SO3 2 minus. Okay, or in other words, that's going to be Kb equals x squared divided by 0.10 minus x. Okay, now for this one right here, the 0.10 minus x, we are going to, just like before, we're going to assume, okay, I'm just going to write here, assume that 0.10 minus x is equal to just 0.10. So I'm just going to write assume here. Okay, and then I'm going to take my equation up here, plug in some numbers like this, 1.0 times 10 to the minus 7, and that equals x squared over 0.10. Okay, I solve for x, and if you do this, x equals 1.0 times 10 to the minus 4 molarity. Okay, and that happens to equal our concentration of OH. Okay, so this is a very important number. Now, the question doesn't ask for the concentration of OH, the question asks for the concentration or the pH of this. So what we're going to do is we are going to calculate the pOH, which is going to equal the negative log of this number 1.0 times 10 to the minus 4. And this one you don't even need your calculator to do it, but the pOH equals 4.00. Remember, this is 2 sig figs. And if you then calculate the pH, which is 14 equals pH plus pOH, you'll find that pH equals 10.00. Okay? And that makes sense. Our solution, what we're adding in here is a basic salt, and therefore our pH is basic. Okay? Till next time. Bye.